We're going to continue to talk about exponential growth and decay, except we're going to look at examples today where things are compounded or calculated at a different rate rather than annually. So yesterday we focused a lot on annually, and this means one time per year. But we're going to look today at these situations where an interest rate, for example, is compounded or calculated more than once a year. So semi-annually means 2 times per year. Quarterly, think there's 4 quarters in a dollar, so quarterly means 4 times per year. Monthly, we know there are 12 months in a year. Weekly has 52 weeks per year. And then daily, there's 365 days per year, with the exception of a leap year, but we're going to stick with a typical year. So, what does this mean for our exponential growth and decay model? So when it's not compounded annually, the formula is going to look very similar with just some small changes. So first of all, A is still going to be your initial amount. You're going to still have 1 plus for growth. If it were decay, it'd be a 1 minus. And then we typically write our interest rate as a decimal, but when it's not compounded annually, we're going to take that rate and we're going to divide it by the number of times that you're actually calculating or compounding in a year. So that's what N is going to stand for. And then you're going to raise that to the T years times N, the same number here. So let's label some of these things so it makes more sense. So what does N mean? So this N basically stands for the number of times that it's compounded per year. Number of times compounded or calculated per year. So if it's quarterly, then N is going to be 4 in each of these sections. If it's monthly, N is going to be 12 for each. Everything else is what it was in our other formulas. So A is still going to be your initial amount. R is going to be your rate, but that rate, again, is still going to be given as a decimal. So you need to make sure that you change it from a percentage to a decimal. And then T is still going to stand for your time in years. So let's look at some examples with this formula. The biggest thing is after you write the formula, being able to calculate this accurately in your calculator. Example 1, you put $2,000 in the bank, you earn 1.5% interest. However, it's compounded monthly. How much money will you have after 4 years? So your initial amount is $2,000. We're going to multiply this times 1 plus 1.5% as a decimal. If we were to move that decimal 2 spots to the left, is going to be 0.015. And in this case, we're compounded monthly. This means 12 times per year. So your N value is going to equal 12. So you're going to divide 0.015 by 12. We're looking for your total amount after 4 years. So 4 years, but times that 12. So let's talk about how we would do this. Order of operations says we need to focus on parentheses first. Within the parentheses, we have addition as well as division. Division is going to happen first. So if you're doing it step by step in your calculator, you're going to take the 0.015 and divide that by 12. Then you'll be adding 1. So inside the parentheses right now, this value right here is 1.00125, right? That's what we got here. So what I have to do is take that value, and now we have multiplying by 2,000 and raising it to the 4 times 12 power. Well, an exponent trumps multiplying, so we want to raise it to the power of, 4 times 12 is 48. So we're going to take that 1.00125 and raise it to the 48th power. And then we can multiply that times 2,000. Which means you should have in that bank account, after 4 years, compounded monthly, $2,123.59. So what if we took the same situation and instead, still 4 years, what if it was compounded semi-annually? So not quite as often as monthly. Instead of 12 times a year, it's only going to be 2 times per year. So this just adjusts your formula a small amount. We still have the 1 plus 0.015, but instead of dividing by 12, we'd be dividing by 2 and raising it to the 4 times 2 power instead of 4 times 12. So again, following order of operations, if depending on what type of calculator you have, you might be able to type all of this in at once. So I can very carefully input this and say 0.015 divided by 2, and then raising that to the, what was it, the 8th power? Yeah, the 8th power. And in this particular calculator, it is going to follow order of operations. So is it possible to type all of this in at once? It is. But if you're especially on a scientific calculator, I'm hesitant to tell you to type it all in at once. That's why instead I would probably do something like this, where I would take 0.015 and divide that by 2, take that answer and add 1. This is what's inside the parentheses, so 1.0075 gets raised to the 8th power. And then we take that and multiply it by 2,000. And you'll see we get the exact same answer as what I had when I typed it all in at once. So $2,123. And instead of 59 cents, it is what, 20 cents, if we round that appropriately. So it's a small difference when you're comparing to compounding monthly versus compounding semi-annually, but there is a difference.